Welcome to this video on how to simplify square roots, numbers only, no variables. Let's begin. In the past, you have taken the roots of perfect squares. For example, you may know that the square root of 25 is 5, or that the square root of 100 is 10. You may not know, however, that there is a property that helps us simplify non-perfect squares. In other words, numbers that are not perfect squares. This property, quite simply, is as follows. The square root of ab is equal to the square root of a times the square root of b. This is only true if a and b are positive or 0. In other words, they cannot be negative. Example 1. Prove that the square root of 36 is 6 using this property. So we can write the square root of 36 is equal to the square root of 6 times the square root of 6. We can do this because 36 is equal to 6 times 6. From here, we know that the square root of 6 times the square root of 6 is just 6. Another way to think about this is that 36 is also equal to the product of 9 times 4. So we could rewrite this as the square root of 9 times the square root of 4. The square root of 9 is 3, the square root of 4 is 2, and 3 times 2 is 6. This is another way to prove that this is true. Example 2. Simplify the square root of 50 by trying to find perfect squares which are factors of 50. So if we look over here, we see a list of perfect squares. Obviously, we're not interested in any of these values that are larger than 50, so we can ignore these last three. So we have 7 squared is equal to 49, but 49 is not a factor of 50, so that one is not going to work either. We have 6 squared is equal to 36, but 36 does not divide evenly into 50. But what about 5 squared is equal to 25? Does 25 go into 50? It does. In fact, if you factor 50, 50 is 2 times 25. So one way to think about this problem is we can write the square root of 50 is equal to the square root of 2 times 25. In other words, it's the square root of 2 times the square root of 25. Since 25 is a perfect square, we can simplify that and rewrite the square root of 25 as just 5. Now, because sometimes it's confusing where the radical ends and begins, we usually write the number 5 on the left side, and then we write our radical. So our final answer for the square root of 50 would be 5 square roots of 2. So this is one way to approach this problem. But I want to teach you a different way because it's going to help us when we get to higher roots. Another way that always works and that doesn't require you to use this table over here is to simply do a prime factorization of the number. So 50, so think about 50. What goes into 50? Well, we said 2 times 25, right? You could also think of maybe the first thing that comes to mind is 5 times 10. Doesn't matter. And then 10 is 2 times 5. So 5, 2, and 5 are the prime factors of 50. So we can rewrite 50 as 5 times 2 times 5. So let's try looking at it this way. If it's okay with you, I'm going to write the 5s next to each other. Okay? So now what we have, we're looking for pairs of numbers, sets of 2, right? Because that's going to give us a perfect square. We can see that we have 2 5s here. So what happens when we take the square root? I like to be silly and say that these guys are in prison. They're under the radical, right? They're trapped. And when they escape, in order to get out, they have to be a set of 2. And when they escape, only one of them gets out. So we have 1 5 that comes out of the radical. So we have 5 times the square root of 2. Okay, so again, if you are very comfortable and you have the perfect squares memorized, you're absolutely welcome to use this table to find the largest perfect square that's a factor of your number. Again, an equally valid way to do this is to simply do a prime factorization and look for, in this case, pairs of numbers because we're taking the square root or the second root. All right, let's do this next one, the square root of 48. So again, I'm going to do this both ways. So if we look at 48, we need a number over here that is less than 48. So we're definitely ignoring all these. 36 does not divide evenly into 48. 25 does not divide evenly. 16 does. So if we look at 48, 48 is actually 3 times 16. So we could rewrite this as the square root of 48 is equal to the square root of 3 times 16. So we'd have the square root of 3 times the square root of 16. The square root of 16 is a perfect square, so that is 4. Remember, we like to write the integer on the left of the radical. So our final answer would be 4 square roots of 3. Okay, so that is method 1. An equally valid method is to do a prime factorization of 48. So maybe I notice that it's an even number, so I write 2 times 24. And then we can keep going. 2 times 12. 12 is 3 times 4, and 4 is 2 times 2. So the prime factorization, we have to include all of these values. So we have 2 times 2 times 3 times 2 times 2. So we can write the square root of 48 is equal to the square root of 3 times 1, 2, 3, 4. Okay, so now remember what I said. Pairs of numbers can escape, and when they escape, only one of them gets out. Okay, so 1, 2 can escape. A second 2 can escape. Okay, and then what's still under the radical because he doesn't have a buddy to escape with? Well, it's the 3. Then we just do 2 times 2. 2 times 2 is 4. So we have 4 square roots of 3. Again, both of these are equally valid methods. I invite you to pick a one. Don't try to do both of them. Pick the one that appeals the most to you, that seems the most natural and intuitive, and that you think you can do the fastest. All right, example 4. So here we already have a number outside of our radical. We have a 3 outside, and then we have the square root of 50. Well, we've already done the square root of 50, if you recall. We already said that the square root of 50 is equal to, that 50 is equal to 2 times 25. And of course, 25 is a perfect square, so we can rewrite 50 as 5 times the square root of 2. So we can rewrite this as 3 times 5 square roots of 2. Then we need to do this multiplication. 3 times 5 is 15, so our final answer is 15 square roots of 2. Again, if you wanted to do, instead of finding the perfect square, which was 25, you could, again, just do a prime factorization here. You could do 2 times 25, and then 5 times 5. So we would rewrite the square root of 50 as the square root of 2 times 5 times 5. Then we see that there's a pair of 5s, so when they escape, only one makes it out. So we have 5 square roots of 2. Okay, so again, pick whichever method you like. Figure out which one makes the most sense to you. And if you like both of them, I guess you could use them interchangeably. It's up to you. All right, next example. This time we have the square root of 200. So again, I'm going to do this problem both ways. So the first thing is I'll look at this table. Notice that the largest square here is 100. And 100, of course, goes into 200. We can rewrite 200 as the product of 2 times 100. So then we could rewrite this as the square root of 2 times the square root of 100. And again, the square root of 100, as you can see, is 10. So we could rewrite the square root of 200 as 10 times the square root of 2. Okay, again, this is a perfectly valid method. You can also, if that doesn't appeal to you, you could rewrite it, you could start factoring it here. Now, with this prime factorization, you might automatically notice, oh my gosh, 100 is a perfect square, and you could take it from there. If you don't notice that, another thing you could do is you could keep going, right? You could say, well, 100 is 4 times 25, and 4 is 2 times 2, and 25 is 5 times 5. So the prime factorization is going to be these numbers. So you're going to have 2 times 2 times 2 times 5 times 5. So then, remember, we're looking for pairs of numbers to escape. So there's a pair of 2's, so 1 2 escapes. And there is a pair of 5's, so 1 5 escapes. So 2 on the outside, 5 on the outside. What's left inside because he doesn't have a buddy? Well, there's 1 2 left over. So we have 2 times 5 is 10. So we have 10 square roots of 2. Again, both equally valid methods. Pick the one that makes the most sense to you. Example 6. Now we have a negative sign, but that's okay because the negative sign is outside of the radical. So we have negative 7 times the square root of 63. So this time, I'm going to switch it up a little bit. I'm going to do the prime factorization of 63 first. Okay? 63 is 9 times 7, and 9 is a perfect square, 3 times 3. So I can rewrite the square root of 63 as the square root of 3 times 3 times 7. Okay, then we can see that we have a pair of 3's, so one of those is going to escape. So we have 3 on the outside, so we have 3 square roots of 7. Okay, if you don't like doing that method, again, you could use the table. What you will find is that the smallest perfect square that divides into 63 is 9. So then we would rewrite the square root of 63 as the square root of 9 times 7. So we would rewrite it as the square root of 9 times the square root of 7, or 3 square roots of 7. Now, neither one of these are really the final answer, right? Because I sort of ignored this negative 7 that was out here. So let's put the negative 7 back where he's supposed to be so that we can actually get the correct answer for this problem. So put negative 7 out here. Okay. And then, right, so we have negative 7 times that 3 that escaped times the square root of 7. So the final answer is going to be negative 21 square roots of 7. Okay, same thing down here. Let's put in our negative 7. Put in a negative 7 here. Put in a negative 7 here. Put in a negative 7 here. And then we would get negative 7 times 3 square roots of 7. So that would be negative 21 square roots of 7. Okay, so hopefully that wasn't confusing. The first thing I did was I just simplified the square root of 63. Right, so the square root of 63 was equal to 3 square roots of 7, right? And then I just popped the negative 7 next to it. And I just multiplied on the outside. Negative 7 times 3 is negative 21. All right, what about this problem, the square root of negative 25? Well, if we go all the way back to the beginning, we have a problem here, right? Because this property is only true, it says, if A and B are both non-negative, right? So let's think about the square root of negative 25. Well, if I rewrote that, I'd still have a negative sign in here, wouldn't I? I'd have the square root of 5, the negative square root of 5 times the square root of 5. And then if I broke this down further, I would still have something like this, right? And then, remember, again, it doesn't work because you have a negative number here. Okay? In a later section, we will learn how to take the square root of negative numbers. You actually get an imaginary number, so we will learn about that. But for right now, right, we're just going to say that there is no, let's make it specific. There is no real solution. Okay? And it might seem silly, since we don't know about imaginary numbers yet, to say that there's no real solution. Like, well, what does that mean? But again, there are imaginary and complex numbers. We haven't learned about them yet. But for right now, we're just going to say, nope. If there's a negative inside the square root, then we cannot evaluate it. We're just going to leave it alone, say no real solution.